the important part of any talk is to do a selfie. Because did it really happen? If I can't put it on social media and say that I did. Alright, well, everybody looks like you're having a hi, I'm Laurie Voss. I'm the COO of NPM Inc. This is my second time. This is my second time talking at App Academy, but the last time was 3 years ago, so you were in a building that was across town, and of course none of you were born yet. This is the 29th version of this talk. This talk has been pretty popular perennially for the last couple of years, and so at this point it's well refined, and I've been giving it to lots and lots of bootcamp audiences for 5 years now. And you are the perfect audience for this talk. That's why I keep giving it to bootcamp audiences, because it is all about the very next thing that you're about to do. As soon as you are done learning how to do a web app, this is all of the other stuff that you're going to have to learn how to do. So, like I said, I'm the COO of NPM Inc. A COO is a strange person to give a technical talk, and that's because that's not really what I am. What I am is a web developer. I've been a web developer for 22 years. I started doing web development when I was 16 years old, and then I took a break to go to college, and then I was a front-end guy, and then I was a back-end guy, and then I was a DBA for a while, and then I was an ops guy, and then I was the CTO at NPM, and then shit happened, and I became the COO of NPM, but what I really am is a web developer. That's who I identify as, and that's what I really care about, and that's what I'm passionate about. I like websites, and I like making them big, and I like making them fast. So, what are we going to be talking about today? We're going to be talking about the stuff that everybody knows. What I mean is, there are lots of talks about new stuff. There are lots of talks that are trying to persuade you to adopt some framework or something that somebody just invented, or to do something that nobody really does yet. And there are not a lot of talks about the stuff that everybody assumes you already know. The stuff where when you get your first job and you arrive on day one, they ask you to do something and you're like, I've never done that before. I don't even know what that means. And that's because there's stuff that we agreed was true and good like 10 or 15 years ago, and it's still good and it's still true, but nobody gives a talk about it because that's not a particularly exciting thing to give a talk about. But the result is that people who come out of boot camps especially, they arrive on their first day and people get mad at them for not knowing stuff that everyone assumes that they should know, but nobody told them. And that's what this talk is trying to fix. This talk is trying to give you a picture of the big room that you're in so that you can find all of the stuff that you should be exploring. It is not a tutorial, and even in 2 hours I could not possibly give you all of the information about how to be the best web developer you could possibly be. So basically you're in a big dark room and I'm shining a flashlight and going, there's a sofa over there and that's the fridge and that's a big hole that you shouldn't fall into. And I'm turning off the flashlight and I'm going home. And you have the rest of your life to sort of explore the room. And now for a disclaimer, that's a ridiculously arrogant idea for a talk, right? I just walked into the room and was like, I know everything about web development. You people know. This is a ton of opinions glued together. It's opinions from 22 years of being a web developer, so they're not totally unfounded opinions, but they are opinions, and there are people who disagree with me about lots of this stuff. But I'm not going to preface every single thing I say with I think or in my experience. Just assume that's in there. I also ask people on Twitter regularly to sort of give me feedback on this talk. Experienced web developers to tell me, do you think this is important? Should I change this? Is this not popular anymore? That kind of stuff. So this is to some degree a crowdsourced talk as well. But that brings us to the very first thing, which is that I could be wrong and that you could be wrong, and in fact all of us are wrong nearly all of the time because knowing stuff is a thing that humans are bad at. This problem is summarized as a thing called the Dunning-Kreuger Effect. Dunning and Kruger were psychologists who did a study in 2000 about how good people are at things, and how good people think they are at things, and how good people think their coworkers are at things when measured objectively. And how they did it was they gave people some basic measurable tasks and stuff like math and logic and grammar, things where you can have a right and a wrong answer. And they graded them on those things. So they had a sort of objective measure of how good are you at these things where we can actually actively say that you're good or bad at this thing. And then they ask those people who've done the test to grade themselves and to grade their coworkers at those same tasks. So the people who are really, really good at things, they put them into the top quartile, and the people who are really, really bad at things, they put them into the bottom quartile, and they discovered some really interesting things about those people. So the top quartile people, the people who are objectively really good at stuff, think they're just about average. They undervalue themselves. And the other thing that they do is they overestimate how good everybody else is at stuff. This is probably familiar to you as imposter syndrome. Imposter syndrome is when you're so good at something that it feels easy, and because it feels easy, you think you can't be trying very hard, and therefore you think you're not as good at it as you really are. And also, because you think it's easy, you think that everybody else must be pretty good at it because it's easy, right? Everybody must be okay at this. Imposter syndrome is dangerous because it makes you vulnerable to arrogant jerks who are predisposed to believe that you are less good at things. Because you are also predisposed to think you're less good at things, it makes you liable to believe the jerks, which is a huge problem. So, well, I'm going to talk more about this later, but don't let jerks who think that you're less good than you are, just because they walked into the room thinking that, convince you that you're not. But the bottom quartile people, that is the real danger zone. The people in the bottom quartile are absolutely shit at things and they don't know. And that's a real problem. They also think they're about average. The bottom quartile people think they're about average, but what's really interesting is when you ask them to rate how good everybody else is, and they don't underestimate, they don't overestimate, they're just a random number generator. They're just like all over the fucking map. And that's because they don't know what good and bad look like. They're so bad that they don't know that they're doing it badly, and they also don't know that other people are doing it well. And the reason that's a huge problem because it means they don't get better. They have no feedback mechanism, because if you're bad at something and you recognize you're bad at something, then when you do it better, you can be like, okay, I'll just do it better. But if you suck at it so hard that you can't even tell that you're doing badly, you don't get better. The way to get out of the bottom quartile is focused mentoring from somebody experienced, and that is a good thing for boot camps. Boot camps are a way to pull yourself out of Dunning-Kreuger bottom quartile. The way that you know you've exited the bottom quartile is one day you will wake up and have a realization. You'll be like, I know fucking nothing. I am just overwhelmed by my own ignorance of this topic, and that is when you know that you've created the feedback mechanism. When suddenly you're overwhelmed by how dumb you are, that means that you're fine. But the real danger here is that both groups feel the same, right? Like I said, they both feel that they're about average. So if you feel that if you're at that line and you feel pretty okay about yourself, you're either absolutely excellent at this thing or really, really terrible at this thing, and there's no way for you to know which one of those you're in. So this creates this delicate psychological balancing act where you can't let anybody give you shit, but you have to stay humble just in case it turns out that you're terrible. So, after Dunning-Kreuger, the next most important thing to know about your job is to be great at it is to automate everything. Because tasks that take a small amount of time but happen all the time use a surprisingly gigantic amount of your life. This first came to my attention by this thing, which is an XKCD strip, but Randall Munroe doesn't have a job and doesn't really understand how jobs work, so his math was a little weird. So I made my own. It assumes that you've got an 8-hour working day and that you've got about a year to do whatever this thing is. Can you think of a task that you do every single day and it takes you about an hour every day? The answer is typing. If you type at about 30 words per minute, which is sort of, average beginner typing speed, and you could speed up to 40 words per minute, which is still pretty average typing speed, you'd save an hour a day, assuming that you were spending 8 hours a day typing. And by the math of this thing, that means that over a year, you'll have saved yourself 1.5 months of time by going from 30 words per minute to 40 words per minute, which is really not very difficult to do. So if you think about it, if you just entered a startup, and your startup had 12 months of runway, and you were like, I'm going to do nothing for the first 4 weeks, but learn how to type faster, that would still be worth it. You'd still be better than if you just tried to run the whole year as a slow typist. But this is just an example of one of this category of extremely common tasks where getting very, very good at it pays off. And another one is Unix. For better or worse, Unix is where we deploy websites. People use macOS, they use Windows, but when you actually put the website out into the world, it's going to be on some flavor of Unix, it's probably going to be Linux, and it's probably going to be Ubuntu. So you need to be good at the command line. You need to be comfortable on the command line. It can't be this thing that you go to when you have to and you're kind of scared of it. It has to be effortless, because if you have to spend 5 minutes thinking of commands and Googling stuff every time you want to type anything into the command line, you have to do that shit all day. It's your whole life. So you need to take that 5 minutes down to 0 seconds of Googling stuff before you can use stuff on the command line, and suddenly you will be much, much faster. There's this myth in the tech industry of the 10x programmer, and the 10x programmer it's stupid. Nobody programs faster than other people. Everybody programs at the same speed. Some programmers are dramatically more productive than other programmers because all they do is program. They got rid of all of the other stuff. They got rid of all of the endless Googling of stuff that they should know already. They got rid of, basic hygiene, and all they do is code. I don't suggest getting rid of basic hygiene, but I do suggest learning how to be really good at Unix and really good at Bash in particular, and in particular Bash scripts. Every time you have a sequence of commands that you run all the time, like 5 or 6 lines of code, turn that into a script. Turn it into one thing that you don't need to remember those commands anymore. You just need to go test, enter, or deploy, enter, or whatever the fuck it is that you're doing. Turn it into one thing. Get it right one time, get it perfect, and then never think about it again, because again, you're taking 5 minutes or 10 minutes out of your life that you run 50 or 60 times a day and turning it into 0 seconds. Another thing to be really great at is your editor. I don't care which editor you use. You can use Vim, or you can use Emacs, or you can use some piece of technology invented in this century. That would be fine. There's nothing wrong with IDEs. There's nothing bad about them. The important thing about the editor that you pick is to pick it and stick with it forever. There is this group of people who are super good at Vim, who will tell you that Vim is the only thing that real programmers use, and the reason they think that is because they have been using Vim for 30 years. Of course they're good at Vim. They've been using it for 30 years. If you used anything for 30 years, you'd be like a fucking wizard at it. It doesn't matter. Vim is the worst piece of fucking software I've ever used. You have to type a code to do anything. No, the only reason Vim is good is because people are so very, very good at Vim and they invested the time. Use any editor you like, but don't switch all the time. Don't change your keyboard layout to Dvorak. Don't be constantly trying out new fonts and colors, because that's just going to make you slower. And the thing that you want to do is forget your editor is there and just have it be an extension of your brain. So, all of this seems kind of obvious and kind of condescending. I can walk into the room and you need to get faster at typing and learn your editor, and yet there are 20-year veterans of the tech industry who type with 4 fingers and are constantly switching their editor every day, and every time I meet them I'm like, why? Why? How much more value would you have contributed to the world if you hadn't fucked up your editor every 3 weeks trying to find something that was better in some way? So the last thing that you should get really great at is version control. And by version control, I mean Git. There are other ways to do version control, but Git is the only one that matters. Git is how software is made. It is essential to how teams work in the software industry. It is essential to getting your job done. It is essential to deploying. It is essential to editing. It is essential to every process. You will spend all of your life working with Git. So if you're currently at the stage, as I sometimes still embarrassingly find myself, where you do something wrong and a whole bunch of greater than and less than signs show up and you're like, ah shit, I've created a merge conflict again, then you need to get into a place where that goes away. You need to be effortless at Git, at merging, at branching, at squashing stuff down and doing all of the weird Git shit that people do, because again, it's going to be like breathing to you. It has to be like breathing to you because you're going to spend all your time there. So, you've done all of that stuff and now you're ready for actual web development. But what is actual web development? It is not coding all the time. It's about half coding all the time, and that's kind of generous. The other half of your job is communication. The job of every engineer is about communication. If you just write the perfect algorithm, that's great, but how did you know what the problem was? You needed to understand what people were telling you to do and the problems they were having, and particularly the constraints that they were operating under, right? If somebody tells you, okay, write a sorting algorithm, the very first question that comes out of your mind should be, how long do I have to write this thing? Because if you have 6 weeks to write this thing, then you can write an amazingly perfect sorting algorithm. A sorting algorithm is a bad example because everybody should just use pre-written sorting algorithms, but pretend I used a better example. If you've got 6 weeks to do it, then you can do a perfect version of that thing. But often, in a real-world programming situation, in actual industry, they'll be like, it needs to ship tomorrow. And then you'll be like, okay, I will go and find a library that does that thing, right? You fundamentally misunderstood the problem if you think that you have enough time to program a new solution and you don't, right? You need to understand how much can it cost, on how many boxes is it supposed to run, how many users is it going to have. Does it need to be fast or does it need to be accurate? You need to understand the constraints, and then once you've written the thing, you need to be able to communicate those constraints back out to the world. You need to be able to tell your coworkers, well, it's super fast, but it breaks like 1 time in 5. And they'll be like, cool, that was what we wanted, or no, I can't use that under any circumstances, right? Depending on your application, that's going to be true or not. So talking about what you're doing, finding out what other people need you to do, and then telling other people what you have done is absolutely essential to your job in a way that a lot of developers don't understand. So let's move on to the first actual piece of web development, which is HTML. This guy is Tim Berners-Lee, my personal hero. There's not a lot of technologies in the world, especially modern technologies, you can point at one guy and say he invented it, but this is actually true. Like, everybody agrees. Tim, yep, he did it. He invented the web. But he wasn't actually trying to invent the web that we use today. What he was really trying to do was something a lot more like Wikipedia. What he had in mind was a database of knowledge that was two-way editable. The reason search engines know stuff edited, and everybody can interlink, they've analyzed all of the anchor tags. Obviously, the web can do Wikipedia, which ones are linked to where, and it can also do all of the other stuff that the web does. And the reason that's useful is because of this incredibly simple, basic relationship trying to build is still there. That mechanism created the entire web. All of these designed to mark up information. You think about design to be a way of displaying pretty bits on screen readers. So when you write HTML, if all you've done is like written 5,000 divs and a couple of spans, their screen reader is just going to be broken. The screen reader is going to be like, well, there's a tag, here's another tag, here's another tag, here's another tag. And I don't really know which things because I don't know what's the heading and I don't know what's the nav bar. The meaning of tags is where all of the utility of the web. The reason the web is a web is because of the semantic markup of links buzzword for it, because then there's an anchor tag. Their screen reader is going to know what you did. It's going to be like, I'm on a web page, and it has a header, and that thing over there is the information bar, so I'm going to read it. Text inside of this link is an article, this is a pull quote, so I'll read that in a different voice. All of search engines fall out of one tag. Right? The reason search engines know stuff is relevant or not relevant is because they've analyzed all of the anchor tags in the universe and decided which ones are linking to where and what words they were linking to at the time that they did that. It's an extremely complicated algorithm, but it falls out of this incredibly simple, basic relationship. And that mechanism created the entire web, and all of the other tags can do similar things. If you think about how somebody who's using a screen reader is going to be using your website, if all you've done is like written 5,000 divs and a couple of spans, their screen reader is just going to be broken. Their screen reader is going to be like, well, there's a tag, and here's another tag, and here's another tag, and here's another tag, and I don't really know which thing is important, I don't know what's the heading, and I don't know what's the nav bar. I'm just going to read every single piece of text to you on this screen, and it sucks for them. If you've used meaningful tags, if you've used semantic markup, that's the buzzword for it, then their screen reader is going to know what you did. They're going to be like, I'm on a web page, and it has a header, and that thing over there is the nav bar, so I'm not going to read it, and this is the body, and this is an article, and this is a pull quote, so I'll read that in a different voice, and this thing is bold, so I'll make it bolder. All of that stuff is absolutely key to putting information into your website, and putting meaning into your markup will have unexpectedly useful effects for you later on in life. So, I'm going to talk more about accessibility later, but now let's talk about JavaScript, where I should have a ton of opinions because I work for NPM and we are the JavaScript company. But no, it turns out that JavaScript is not a thing that everybody knows, or at least it's not a thing that everybody agrees about. There's no right way to write JavaScript. There are lots of wrong ways to write JavaScript. But the two things that are worth talking about in the realm of JavaScript are that, one, that you don't always need a rich web app, and two, you should consider progressive enhancement. So the first one is about rich web apps. Everybody wants to write a rich web app because rich web apps are more fun to write. They're complicated, you get to use React, you get to do complicated stuff with transitions and things, you get to build a beautiful, Flux workflow to put everything back, put all of your events through your web app. It's fun, but it's not always necessary. In some cases, in fact, often, it's not a good idea. A rich web app has trade-offs. It takes longer to load, it's more complicated. If you haven't put in some effort, it will probably not render until it hits the client, which is a huge problem for search engines. What is your site for? Is your site an application? Is it like a photo editor, or is it an email client? Is it something where people land and they take a long time to mess around with stuff? Or is it something where displaying the information as fast as possible is key? Is it like a news site? The New York Times is not a rich web app, and the New York Times is never going to be a rich web app, because the only thing that you do on the New York Times is you smack onto it, and you read the page, and then you maybe scroll a little bit, and then you leave. There's no functionality on the New York Times, and it will never be worthwhile to add any. So the New York Times is always going to be a flat website. The other consideration is that more than 50% of the web, more than 50% of the time that people spend on the web these days is spent on phones. That's a reality that web development hasn't really caught up to. And the thing about phones is that they're super convenient, but they're kind of shitty as web browsers, right? They have really slow and unreliable internet connections. They don't execute JavaScript as fast. And if 80%, if you're like a mobile website and 80 or 90% of your users are coming in on a phone, then making a rich web app is a terrible idea, because you've added like 5 or 10 seconds to their load time, and people on phones do not have 5 or 10 seconds to spend on you. They will get bored after second 3 and fuck off. So you have to consider, again, this is about considering the constraints that you're operating under. The second thing is using JavaScript optionally, which is a concept called progressive enhancement. It was an old idea that gained popularity again. Progressive enhancement is easily expressed as the idea of what happens to your website if JavaScript is turned off. And that seems like a stupid question, because who the hell turns off JavaScript? Everybody runs with JavaScript enabled, but 100% of people run with JavaScript disabled until all of the JavaScript is loaded. It's the last thing to happen. So if ever your page is loading, especially on a phone, and the connection gets interrupted halfway through because they're on a train or they went around a corner in San Francisco, suddenly your JavaScript doesn't load, and now none of your website works because it's a rich web app and it doesn't work until everything is loaded. And that could be a huge problem for you. If what you're trying to do is sell something or inform somebody, and your website doesn't work unless every single last bit of code loads and executes perfectly, then you're probably not doing a great job as a web developer. What you want is to just slam that information onto the screen as fast as you possibly can, and then add all of the pretty stuff later, because your users are going to be impatient, and they're going to have broken and terrible web browsers. One of the ways that you can have the best of both worlds, if you really, really are tied to your rich web app, is to have server-side rendering of your rich web app. So you deliver some HTML immediately, it works, and then you hydrate it later so that it turns into a rich web app. My favorite example of this is Google Sheets. Google Sheets is a tremendously complicated web app. It's a wonderful piece of software. And if you've ever loaded a Google spreadsheet, you might have noticed something really interesting, which is that the thing that it sends you and the thing that you use are totally different things. What it does is it sends you a table that is the very first version of the very first square that you can see, that contains all of the information on the first sheet of the spreadsheet. And then, while your slow monkey brain is like looking around for the first button to click and deciding what to do, it is frantically in the background loading an entirely separate complex web app and then swapping it in seamlessly without you noticing. It is doing both of those things because it was absolutely worth it for them to be able to show the spreadsheet as fast as possible and give your monkey brain something to do while it was doing all the other stuff. I frequently refer to people in UX and software conversations as monkeys, because monkeys are a really great analogy for how people behave when they're using software. We're super impatient, we're noisy, and we throw feces at the wall when we are pissed. The next thing to talk about is user experience. User experience is not what it looks like, that's UI. User experience is what it feels like, what it works like. And it is far more important. If you ever have a situation where you're trading off between what it looks like and what it feels like, always go for what it feels like, because that is the thing that people remember. UX starts before you even visit the web page. UX starts at what your URL looks like. HTTP, the thing that underlies the web, is a stateless protocol. And that's a very important feature that people forget is important. Its greatest strength is if you pass someone a URL, it is a promise that the thing that you're looking at that URL is going to be the same thing that they see. That seems really obvious, right? I cut and paste a URL and I send it to you and you see the same thing that I see, but nothing else works like that. You can't do that with a desktop application. You can't do that with an app on iOS. You can't do that with any other form of software. But web software can teleport from one user to another. The reason all social mechanisms are built upon the web, the reason the web is this tremendous social platform is because of the stateless nature of HTTP and the fact that we can send each other around within applications, which is a mind-blowing concept that we've all just got completely blasé about. So the important thing about that is to not break your URLs, because as soon as you've created a URL, the monkeys will have started sharing your URL amongst themselves, and they will put it on billboards, and they will put it on books, and they will put it on stickers. And it's important that your URLs work forever, because you can't change the URLs that come to your web page, and people will use them forever. You should also support deep links. This is especially important if you're using a rich web app. A rich web app has state, right? It starts at the home page and it loads the initial interface, and then you go deep down into the web app and you're like, you're 3 clicks in and you've slid this thing down, and you've opened up a box and you've hit a button. Your URL should reflect all of that stuff, because people are going to try and share the current thing they're looking at. They're going to try and use that promise. They're going to copy and paste the photo in their album that they've reached, send it to grandma. Grandma's going to load your page, and if you've done your job, grandma will see exactly the same photo, and if you've not done it, grandma will see the front page of your web app, which sucks. Grandma will be pissed, the person who sent the photo will be pissed, everybody will be pissed at you, and it's because you broke the promise of the web. My favorite example of this is this. Twitter did this in 2010. They turned Twitter into a rich web app, and for IE6 compatibility reasons, which is a dumb reason to do anything, they decided that they couldn't use push state. They had to use these things, hash bang URLs. That hash and the bang in the middle, that's why they're called that. A hash is a URL fragment, and what that means is that the browser doesn't care about it. The browser just assumes that the JavaScript will take care of it in some way, and what it sends to the server is everything until the hash. So if you baked this into an article or something, anybody loading that thing is actually just loading twitter.com. And then twitter.com is frantically deciding every single time you load the homepage, are you trying to see Twitter's homepage, or are you trying to see any one of about 1.8 billion possible tweets? This is this ridiculous task that Twitter foisted upon itself forever. Twitter's homepage, if you load it, you'll see even today, if you just go to the front page of twitter.com and you're not logged in, it'll blink, because it was trying to decide whether or not you were looking at a tweet or whether you were looking at the homepage, and that blink is baked in forever. They forever made their homepage slower because of this one decision that they made 8 years ago. So, the next principle of UX is that you should be solving the user's problems and not your problems. You should be aiming for usability over impressiveness. One of the fun things about UX research is that there's tons and tons of UX research. People have poured time and money into researching how UX works and what we should do. And one of the sad tragedies of the web is that we consistently ignore it, and we've been ignoring it for 20 years, and we're doing exactly the same stupid shit that we were doing 20 years ago, despite the fact that we have all of this research telling us that it's wrong. My favorite example is carousels. By carousel, I mean, like an image that you can, a whole bunch of images that you can scroll through with, there's little arrows and these little dots at the bottom to tell you where you are. The thing about carousels is that users do not know what the fuck they are, and they don't know how to use them, and they hate them. And that is what 20 years of research into carousels has proven over and over and over. It's not that they don't like using them, it's that they don't even know that they're there. They don't spot the arrows, they do not know what the little dots mean, If you give somebody a carousel, you have given them the first thing in the carousel and only that thing. They will never click through your carousel. And if you try to solve that problem by adding auto rotation to your carousel so that the images slide by, all you do is enrage the monkey because they were reading the first thing and it slid off to the side. And they're like, oh fuck, I wanted to, and it's gone. And they can't get it back because they don't know what the arrows are for and they don't know what the dots mean. They can never get it back. It's just gone. And this is what all the research has been telling us for like 15 years now, and yet nevertheless, we keep putting carousels on them. I blame Apple, because Apple keeps putting carousels on its website, so everybody assumes that Apple knows what it's doing. It does not. Apple is not good at web pages. The thing that carousels do is that they resolve arguments in the marketing department. Right? The marketing department is like, we should have this image on the homepage, and somebody else is like, no, we should have this image on the homepage, and a carousel lets you say, we put both on the homepage, it's fine. That's solving your problem, not the user's problem. The user did not care. You have to pick one, because you only get to show one. The next big principle of UX is to be predictable. And by predictable, I mean you should not break implicit promises that have been made to the user. The most obvious one of those I mentioned already, which is the URL. Another big one is how links work and how buttons work. Again, this seems super obvious, but we break it all the time. A link is a thing that you click and it takes you somewhere else, and if you go backwards, nothing has changed. It is a way of exploring a space, and it's completely reversible. A button is a thing that does something. You click it and something has changed. You've created something, you've added something, you've deleted something, you've sent a message, something like that. If you create a link that does something irreversible, your user will be pissed off. If you create a button that does something reversible, your user will be merely confused. The thing about UX is that people don't usually, they don't know that you're getting it wrong. They don't send you angry emails, like, my user expectations were violated and I felt slightly uncomfortable. There's never an email that you're going to get. You're just going to get a bunch of users who are slightly uncomfortable using your website and will prefer to use some other website that doesn't break their expectations. Bad UX is this sort of creeping accumulation of bad feelings until people decide to go elsewhere because you've made them feel kind of icky using your website. Another one that you shouldn't do is you should not fuck with scrolling under any circumstances. It is fun to add parallax effects and CSS transitions that mean as they scroll, stuff comes in from the side, or it fades, or it flips, or it swirls around again. Apple does this all the time. People hate that, it turns out, because we are monkeys, and monkeys only have a certain number of senses, and they were all inherited from when we lived on the savannah, and almost none of those senses work online. We can't lick things or eat them or try to have sex with them. But the one thing that we were able to do that still works online is we can remember where things are when we're not looking at them anymore. I know that my Coke bottle, which I'm about to knock over, is roughly here. And I knew that without looking at it, because I have spatial awareness baked into my monkey brain since billions of years ago. That works on the web. If you're looking at a web page and you scroll down the web page, you know that the login button is still up there, even though you can't see it anymore. It's this reassuring sense that you're on a physical object that makes the web page work. If you've added a whole bunch of weird, funky CSS transitions, suddenly the monkey is confused, and they don't know where anything is, and they don't know how to get back to it, and it makes them uncomfortable, and they go to some other website. So, don't break our only sense that works. And one more far too frequently overlooked aspect of UX is performance. In any situation where you are trading a feature for speed, you should always go for speed. People prefer speed to any other aspect of a web page you could possibly invent. Speed encourages exploration. People will allow you to have a really shitty web interface if it's super fast, because if it's super fast, they can click into it and discover that's not the thing that they wanted, and they can go back. If every single click on your website costs them a second or two, they're soon going to get really bored. They're not going to consider it worth exploring your user interface to find out how things work. So, in all situations, trade speed for whatever. Trade in favor of speed over any other thing that you could possibly get. And like I said, as of 2015, the majority of time spent accessing the web is from mobile. This is not going to be true for every website. NPM's own website is only accessed by about 8% mobile users. But that's really interesting, right? Because NPM's website doesn't do anything on a phone, right? All you can do is like read package readmes. And it turns out that is what the 8% of people are doing. What they're doing is they're coding on a laptop and they don't have enough screen real estate, so they open the documentation on their phone. That is what our research showed. Apparently this is how Gen Z programs, I don't know. But you have to consider the mobile case, and in fact, you have to consider the mobile case first. Like I said, it's where the majority of web access comes for the majority of websites. So most of the time, what you are doing is you're building a web app that is going to be used on a phone, and occasionally, if people really, really like you, they will do the horrible work of getting up and walking 10 feet to a larger screen and using it there. But most of the time, they're going to be on a phone, and you have to consider the phone case first. The last thing about UX is accessibility. Accessibility is not optional. I already talked about how adding semantic information to your web page is going to make your website more accessible. The reason it's important is because something like 3.4% of all users using the web have limited vision in some way. They're not all completely blind. Lots of people just need high contrast, or they need really big fonts, or they need stuff moved around so that they can, or they are changing fonts on you so that they can accommodate their dyslexia. And then there's a bunch of other people with other forms of accessibility needs. There are people who are colorblind. There are people with motor control difficulties. If you make a really tiny fiddly button, some people are just not going to be able to navigate accurately to that button and click it. And that is a really stupid reason to be losing a customer. They're like, I wanted to buy your software, but I couldn't click the fucking button, so I went to eBay instead. People will have strange screen sizes and resolutions. And a bunch of people will have no screen at all. A bunch of people will have things that are reading stuff to them, or patterns of pins that are pointing up into Braille for them. Things that you can't possibly imagine work, that you can't possibly conceptualize, work for them. And the best way to accommodate accessibility is to use browser-based controls as often as you possibly can. Browsers have form controls. They have buttons. They have drop-downs. They have radio buttons, all that kind of thing. And you could do all of the work that they do using a mess of divs, right? Like, it's often easier to style a div as a list of things, but you should use real drop-downs and real selects, because things that are not visual web browsers know what those mean. If you're trying to select from multiple options on an audio browser, it knows that there's 8 options in this list and will allow them to select between them. If it's just a bunch of divs and JavaScript, the audio browser is just like, there's a bunch of divs and JavaScript on this screen, and I don't really know what to do, so this user can't buy your stuff. Something like 10% of your audience is going to have some kind of accessibility need, and throwing away 10% of your revenue because you were too lazy to add accessibility to your website is a dumb reason to lose 10% of your revenue. So, we're moving down the stack is what we're doing. This talk starts at front-end stuff, it goes down all the way to databases and stuff, and then it comes back up. And we're down at the bottom here in databases. I used to have a huge section on all of the databases, but I tried to make this talk a little bit shorter. So instead I will say that there is no database that is always good. They all have different trade-offs, they all suck under different conditions. There is no database that you can pick and say, that's my favorite database, and I'm going to build every application in that. So learn about as many databases as you can. Don't go searching for one true database and then never investigate the other options. Think about, again, the constraints that you're operating under when you're building an application before you pick the database that you're going to build it into. How are we doing so far? I did actually cheat and throw in the section with all of the databases in it, and we can go into it, but only if you all opt in. Do you want to hear about the databases?
Please.
Okay. So, the first database, or rather not a database, that you should consider is memory. Memory, it's not a database, it's just the thing that you could use instead of databases. You don't always need a database. Sometimes you can just cram shit into memory and leave it there, and you're never really going to need to write it to disk. You should consider everything in terms of, what if I just didn't write it down? An alternative to keeping just everything in memory is Redis. Redis is incredibly popular and flexible. Oh, sorry, whoops. I added this slide an hour ago and forgot it was there. An alternative to all of this stuff is IndexedDB. If your use case is, I'm writing a web app and my web app needs to store a bunch of data, but I don't really need it persistent for any length of time after that. I just have a whole bunch of information and I need it used within this web app. Then IndexedDB is an excellent way of doing that. IndexedDB is built into every web app, into every browser, so it's available for you. It's like an object store. You can put stuff into it and pull it back out really fast, and you can do queries on it, so you can find bunches of things at the same time. You can query it from web workers, which is cool if you're doing a particularly complicated web app. But of course, it only works if you're in one browser. So if you want somebody to be able to use it on their phone and then move to their laptop, this isn't going to work because the information is stuck on their phone. So then you want a real database, and the first of those is Redis. Redis, like memory, like IndexedDB, it stores anything you want. It will store whole objects with all of their information and all of their details. It will store functions if you want it to. And it can be accessed from many machines at once, so you can have a whole fleet of front-end boxes that are all talking to this one central database, which is a key feature. And it persists things to disk every 200 milliseconds, and that is an important constraint to understand about Redis. If you are cramming a bunch of stuff into Redis, and Redis loses power, or the machine reboots or something, anything that happened in the final 200 milliseconds is gone forever. Redis will not know that it happened, even if it told you that it did. If you are writing the majority of web apps, that's not going to be a problem. Probably it's not going to be important what happened in the last 200 milliseconds. If you're writing a financial application, you do not want to forget that somebody sent money somewhere. You don't want that to be a possibility. If you are writing a game, the last 200 milliseconds is probably when somebody got the headshot that won the game, and they're going to be pissed if you've forgotten that that happened. So those are the constraints again. Sometimes Redis is going to be fine. In fact, a lot of the time Redis is going to be fine. But sometimes you just can't deal with that. It also has a bunch of cool features like atomic operations, so you can use it for queues and you can use it for locks and stuff like that. We use it a lot at NPM. The next database is the one that you probably heard the most about, which is MongoDB. I'm not MongoDB's biggest fan. It is great for prototypes because it's really simple to use and really fast to get up and running. It claims to be a schemaless DB, but it is not a schemaless DB. It has a schema, it just lives in your code. So if you have two versions of your code running at the same time, and they disagree about what the schema is, suddenly you have an irreconcilable problem where all of your data will get corrupted, and that's kind of a Mongo problem. Mongo, the company, went IPO very recently, so obviously they're doing okay. They have found enough users to keep them sustainable, or so it seems. But pets.com went IPO, so who knows? None of you are old enough to remember Pets.com. It went IPO in 1994, and then it went bankrupt a year later, and the only thing that they sold was a puppet that was their mascot. They didn't actually sell any pet supplies.
Yeah, Super Bowl ad.
Right, and they had a huge Super Bowl ad. So the next database is MySQL, by which I mean MariaDB. MySQL was what the database used to be called, and then it got bought in by Sun, and then Sun got bought by Oracle, and Oracle has its own database, so it doesn't like MySQL very much, and so MySQL has been sort of crushed under the boot of Oracle. But the guy who invented MySQL went and created his own new version of MySQL called MariaDB. The fun fact about that is that the reason it's called MariaDB is because it's named after his daughter, and so is MySQL. He has a son called Miles, and that is why MySQL is called MySQL. It's not my as in mine, it's my as in Miles. And he created a third database called MaxDB, and you're like, MaxDB, like maximum. No, he has a son called Max. That's what Monty does, is he invents databases and names them after his children. MySQL is the de facto relational database. It's what everybody thinks about when they think about a relational database. It's what all other relational databases are viewed relative to. It's extremely easy to install, it's extremely easy to use, it has most of the features that you're going to require, it is fine. The next database is Postgres, which is better in every way, except that it is much harder to install. Postgres has more features, it is more scalable, it does a lot more stuff, it has JSON as a first-class data type, so if the thing that you like about MongoDB is that you can store objects in it and pull them right back out, Postgres can do that, but better, but with indexes and geospatial indexing and stuff. The only problem with Postgres, like I said, is that it's really hard to install, and for some reason, the people who write Postgres have been writing Postgres for 25 years now, and it's still not occurred to them that maybe we should make it a little bit easier to install and run. For some reason, that's still not a priority of the Postgres team, so get somebody else to install Postgres for you, and then use that. The next one up is Oracle. Oracle is the granddaddy of databases. It does everything, it is amazing, and it is very, very, very expensive. You are not going to get Oracle into the building for less than $600,000, which is a lot of money. And this is a key thing about about your first working experience, especially if you're working at a startup, you're often going to be working at startups that have a lot of funding and no time. And if you do that, sometimes you can be a hero by just setting money on fire. They're like, we built this thing on Postgres and it's too slow and we can't make it scale and we don't know how to do it. You're like, I know, let's set $1 million on fire and buy Oracle instead, and suddenly your web app will be 5 times faster and will scale again, and everyone will be like, hooray, the hero who set the money on fire and we shipped on time. Like, that's sometimes a real thing. Sometimes you want to do that. And Oracle is great because it comes with a person. That's what your $600,000 buys you, is somebody who shows up along with the database and is like, I know how to make this work, which is wonderful. The next database is Elasticsearch. Elasticsearch it's not a general purpose database, it's one of a category of specialized databases for search. It allows you to do things that are important if what you're trying to do is search. So if you're trying to index a bunch of different fields and you're trying to say like headlines are more important than the body of text, or stuff in links is more important than the rest of that, Elasticsearch can do that. It can also do stuff like stemming. So if you search for like story, it will also find stuff like stories, because plurals. All of that stuff is just automatic and for free in Elasticsearch, and if you're doing any kind of search, that's what you should use. What you should not do with Elasticsearch is use it as a final source of truth. Because right there in the documentation, Elasticsearch tells you the truth about Elasticsearch, which is occasionally it will freak out and drop everything on the floor. It will forget everything. You will need to refill your Elasticsearch. Kind of a bad feature as far as I'm concerned, but as long as you know about it, you can work it out. Just put the real information in a database and use Elasticsearch as this incredibly flexible cache. So, and the final stop on this tour is the file system. Like memory, the file system is not really a database, but it is an excellent place to store information nearly all of the time. It is flexible, it is scalable, it is searchable, it is easy to replicate, it is easy to back up. A great example of this is LinkedIn. LinkedIn had, billions of dollars and some of the best programmers in the world, and they needed to build a message bus system to move information around. And so they built this system called Kafka by locking a bunch of geniuses in a room and telling them, build us the fastest message bus system you can possibly build. And they could have done anything, right? They could have invented their own database, they could have built a new network format, they could have done anything, but what Kafka does is it just slams stuff onto the file system and leaves it there until you ask for it again, and then it pulls it back up off of the file system, because file systems are great, it turns out. They're absolutely great at caching and remembering stuff and optimizing for frequent reads and all the kinds of things that a message bus needs to do. An alternative to the file system, if you're worried that your file system might explode or you don't want only one of it, is Amazon's S3 system and also the competitors from the other clouds. If you're just like, I have a bunch of image files and I need to put them somewhere, don't put them in a database, for the love of God. Don't put binary information in databases. You can put them on the file system, but if you really care about them, put them on S3. S3 is really slow, but it just scales forever. You can just throw infinite money at infinite numbers of objects, and S3 will store all of your stuff forever, and you can always get it back out because their uptime guarantees are mystical. Like, there's more chance of like the Earth getting destroyed by a comet impact than of S3 forgetting your information, according to Jeff Bezos. So, one of the features that all of these databases have in common is replication. They all have different strategies for doing this, but replication is a way of making your database scale by making more copies of your database. And the concept is really simple. So imagine you have this one database and that's all you've got, and it's doing 10,000 queries per second. Your database is on fire because that's a lot of queries per second to do. But you've looked at your database and you've discovered that there's only about 10 queries per second that are writes, and the other 999,000 are reads. So what you can do is you can set up a chain of replication. Every time you get a write to this database, it will write to these two databases, and these two databases will write to those four databases, and you point all of your reads at these things. Suddenly, all of these four are doing 2,500 requests per second, which is fine, and this one is doing the same 10 requests per second that it was doing the whole time, and suddenly your database is apparently much bigger. You've not changed anything about your database, you've not changed anything about your application, but your replication has suddenly allowed your database to scale. Lots of databases do replication. Some of them it's easier than others. This is how NPM scales. Every time you publish a package, a gigantic tree of replication happens, and it is replicated to everywhere in the world so that every time you download a package, it comes down in 50 milliseconds. That is the chain of replication at NPM. What it's not is a backup strategy. If you have a big set of replicated databases, it's tempting to think, okay, well, we have 18 copies of this information, so it's never going to die. That's going to be fine. Your cautionary tale here is a company called Magnolia. You've never heard of Magnolia because it went out of business, and the reason it went out of business is because it thought that replication was a backup strategy. They had a database set up like this. They had, it scaled out this way, and they were like, if the first one fails, we'll just, move all of our application to point to the second one, and that will be fine. But what they didn't think is, what if we run a bad command? What if somebody accidentally runs drop table on the top database? And that is what happened. The drop table faithfully replicated down to all of the other 4 databases, and it dropped all of the tables, and suddenly all of the data was gone, and there were no backups. And Magnolia just went, oh, we're out of business, because our business was storing your data, and we deleted it all, and we're pretty sure you're never going to trust us again, so we're done. And they closed up shop. So, speaking of backups, whatever database you need, whatever database you choose, you've got to have backups. And you must restore your backups every day. This is a problem that bites really, really big companies. GitLab ran into this the other day. GitLab had like 8 hours of downtime or something because they'd done all of these backups, but none of them worked. They had like 4 forms of backup, and then something went wrong with their primary database, and they went to the first backup, and they discovered it wasn't actually backing up, and they went to the second one and discovered the disk had filled, and they went to the third one and discovered that it was actually on Mars. Like, all 4 were wrong because they'd never done a restore from any of their backups, and so they didn't know that they worked. You have to consider not just that your backups are happening and that your restores are working, but also you need to consider the security of your backups. Your backups should be in some way spatially and permissions-wise separated from your main database. And your cautionary tale here is a company called CodeSpaces. CodeSpaces, again, you've not heard of it, they were a sort of GitHub competitor. And their sort of unique selling point versus GitHub was that they had shit tons of backups. They backed up everything. There were 1 billion copies of your data. You would never lose any version ever. And they had it all in a big carousel on their front page. But what they didn't consider, the edge case that didn't occur to them, was what happens if somebody gets our Amazon password and doesn't like us? And that's what happened. Somebody broke into CodeSpaces and overnight deleted every single instance, deleted every single volume, detached everything from everything else, and destroyed their whole company overnight. And they woke up the next morning and the company was gone. All of the data had evaporated back into the cloud, and there was no way to get it back because that is how clouds work. So your backups need to be somewhere where not even you could delete them if you were in a fit of anger. Security, because people are jerks. People will try and steal your stuff, and even if people don't try to steal your stuff, sometimes people will just break in because they're curious, and then once they're broken in, they will just trash the place because why the hell not? We're terrible monkeys and we throw shit around. Security is one of the things that people mention most often as a thing that junior developers don't know anything about. People walk in the door and they're like, don't do that for the love of God. We worked out 20 years ago that that's dangerous. And people are like, what? You tell me there was no course on this. The 2 big principles of security that I want to talk about, 3 big principles. The first is that you can't add it later. Security is not a phase in your development. Security is not like we spent 6 weeks building the product and then we spent a week adding security to it. Security is a process where every time you make a decision, you consider how that decision could go wrong. You imagine what could happen if somebody decided to abuse that thing that you've just created. And there's no possible way to do it later because after 6 weeks of writing software, you've made 1,000 decisions. And if you had to go back and try to remember all 1,000 decisions, A, you wouldn't remember them. And B, what if the very first decision you made was insecure? Probably the other 999 are now broken. So security is a thing that you have to build into your life as a thing that will slow you down, but is absolutely necessary. The second principle of security is that you should never, ever trust the user. The user is frequently evil, and they are always dumb. So even if they're not trying to break stuff, they will sometimes accidentally break stuff, and it won't be their fault, it will be your fault, because I told you that that would happen. One of the most common ways that people decide that security is not necessary is like, oh, this is just an internal application, nobody will ever use it. There are many, many ways for somebody who is not inside of your network to hijack the web browser of somebody who is. And as soon as they have access to that person's web browser, they have access to all of the web applications inside of your network. And again, they can start attacking you. There's no such thing as a web app that has only friendly users. Even if you're positive that the user is the user who they say they are, they might still not be that user. They might be a botnet that has stolen that user's credentials and is trying to hammer your server or steal all of their information. So even if you've authenticated the user, you still can't trust them to do something that isn't harmful to you or harmful to them, right? Like if you're writing a financial application, if your financial application doesn't consider what happens if the user tries to send all of their money unexpectedly to China with no warning, that's bad. It's probably not a normal thing for them to do unless your application is literally, the Bank of China, and sending your money to China is a regular thing that you would expect them to do. A lot of the time, you're going to have to build in safeguards that you would for your users doing things that are strange or unexpected, because your user is not always the person that you think that they are. And the third one is defense in depth. There is no such thing as perfect security. There's no such thing as a mechanism that will protect you from everything. So the only thing that you can do with security is add layers and layers and layers and layers of security, such that it takes so long to get through those layers that the attacker either gets bored and decides it isn't worth it, or you notice that it's happening, right? They're through 8 levels of security. They've got through your firewall, they've hijacked somebody's browser, now they're decrypting your database, and that's when you notice. Right? If you have multiple layers, that's happened. But if you had only one layer, if you had only one form of security, then your database was probably already stolen by the time you noticed it was happening. So, protect your network, protect your database, hash your passwords, salt the hashes. Does everybody know what I mean when I talk about those things? Good. It didn't used to be on bootcamp curriculum. And it used to drive me crazy. And the security section is another one of those ones that used to be a lot longer, and I've compressed it down a lot. If there's one thing that I can say about security, it is that it is about input validation. Input validation is about codifying this distrust of your users that I just said that you should have. It's about saying that you should define what you're expecting and reject anything that isn't what you're expecting. If what you've got is a username field, then you should check that the things put into your username field look like a username and not like, say, a credit card. This is not a hypothetical example. It is a regular problem with forum websites that require payment that somebody types their credit card into the username field and then sends an emergency bug ticket going, everyone can see my credit card number, why is your site so insecure? That is your fault, not their fault, because you should have checked that they were typing in something that looked like a username and not a 16-digit number that looks obviously like a credit card. So you should reject anything that doesn't match what you're expecting it to look like, and you should reject it on the client in JavaScript before they send it to you, and also again on the server, because again, you can't trust the user. You can't trust the thing that is contacting your API to be the same web app that you're expecting. They're going to sniff through your packets and they're going to find where that goes, and if your API accepts unsafe input but your web app doesn't, then your API is unsafe. So, moving from security to performance. Performance is another huge topic that is worth spending a little bit more time on. There's lots of ways of measuring performance. There's speed, and there's efficiency, and there's throughput, and there's latency. But the good news for you is that really the only one that you should spend any time caring about is speed. It's the only one that users really give a shit about, and therefore the only one that you should give a shit about, because why are you solving things other than your users' problems? This terrifying graph is how many people abandon your web page after how many seconds of waiting for it to load. This information is a couple of years old, and it's also about desktop applications. Down at the bottom I have stuff about mobile web. So after 2 seconds, 12% of your users have already fucked off and got bored. And after 4 seconds, a quarter of them are gone. They could not wait for you. So if your web page is taking 5 seconds to load, you've thrown away 25%, more than 25% of your revenue just by being too slow, because you were like, I must have this JavaScript widget and it must load before I let anybody do anything. As I said in the UX section, the overriding thing that people care about when you're putting a web app together is how fast it is, or how fast it feels at least. If you can make your web app faster by buying more hardware, buy more hardware. If you can make your web app faster by doing less unnecessary stuff, do less stuff. The best example of this principle in action is the Google search result pages. Google search result pages are 10 blue links and a little bit of text, and they've been 10 blue links and a little bit of text since the beginning of time, and that is not because Google doesn't have enough engineers to make their search engine more complicated. It's because anytime they make that page even slightly more complicated, anytime they add any more functionality at all to that web page, it makes it slower, and when it makes it slower, people do fewer searches. Right? Even if it's 0.1% fewer searches, 0.1% fewer searches at Google scale is millions and millions and millions of dollars. So they don't do it. They don't do anything to make searches slower. And in fact, they do absurd things to make searches faster. Like they reinvented HTTP and called it HTTP2. They built their own browser whose only purpose is so that you can load Google search results a little bit faster because they made the browser fast and then everybody copied their technology. Google understands that getting stuff fast is the most important thing. On a mobile website, like I said, more than 50% of the web is mobile. On a mobile website, about half of pages are abandoned in 3 seconds. So if your mobile website, if you've done, your cool, rich web app, and it takes 4 seconds to load on a phone, you've thrown away half of your users. So if all you can do on a mobile web app to get your information loaded is just give them a flat file and it loads in 2 seconds, that is better than any possible other thing that you could do that takes more time. So this changes a lot about what we do, right? Like if you're like, oh, I've got to build this React app because React apps are really fun, and you're like, but it takes 4 seconds to load on a mobile phone. No, you're doomed. You need to send them flat HTML and rethink your solution because it's not going to work. You've thrown away half of your audience. So the next aspect of performance is efficiency. A lot of people confuse efficiency and speed because they think of hardware as being a fixed asset. If you've got one computer and you make your application twice as efficient, then it's going to go twice as fast, and you've got some speed. That's great. But the other way that you could have made everything go twice as fast is just buy 2 boxes and put stuff on that. And hardware is much, much cheaper than your time, which is a thing that it's hard to remember when you have no money at all. But when you're working in a startup, you're going to have to remember, we're going to have millions and millions of dollars and like 4 developers, and you need to spend as much money as possible to make sure that the developers do as little work as possible. So put it on as many boxes as it will fit on, because that's always going to be cheaper. If you want to optimize for efficiency, you should optimize for efficiency when you've got like 100 boxes, right? When you've got 100 boxes, your bill is approaching like $10,000 a month. At that point, if you could make your app twice as fast, you might save enough money that you could hire an extra person. As soon as you hit that threshold, then you're like, yes, we do need more people more than we need these extra 50 boxes. So that's a good idea, but only then. The next aspect of performance is latency. Latency feels like speed, but is not quite the same thing. Speed is how long does it take my web application to do something after I ask it to do something. Latency is how long after my user requests something do they get a response. If your user is sitting right next to your computer, then their speed and their latency are the same thing. It takes 0.1 seconds for your app to decide what to do. The response will come back in 0.1 seconds. You're done. If the user is in Australia, then it's going to take light 500 milliseconds to get to Australia. Then it's going to take an answer to arrive from Australia to you. Then it's going to take 0.1 seconds. Then it's going to take 500 milliseconds to get back. And exactly the same web app is going to take 1.1 seconds. It's going to be 10 times slower in Australia. And it's not your fault. There's nothing you can do. People live in Australia, even though we tell them not to. So you have to come up with some way of dealing with latency. The 2 ways to deal with latency are to make things closer in space and to make things closer in time. One of the greatest ways to reduce latency is a CDN, or a content delivery network. What a CDN does is it puts thousands of servers around the world, and then it uses the magic of multicast DNS so that when somebody requests your domain, instead of going to one computer in an Amazon data center somewhere, it goes to the physically closest computer. So suddenly, the response that they've asked for, instead of coming from your computer, is coming from one of your CDN's computers in Australia, and they're back down to the 0.1 seconds of latency which you wanted. CDNs are magical like that. You can just do stuff and suddenly your application's latency is dropped for everyone in the world, and you didn't have to change anything about your application or become any smarter as a developer. don't build your own CDN, and they're very expensive. So again, this is one of those situations where you want to be at a startup that has a lot of funding so that you can throw money at the problem. The other way to reduce latency is taking the exact same data and put it somewhere faster. So if you followed my advice from earlier and you put all of your images in S3, the thing about S3 is that it's infinitely scalable, but it's also kind of slow. So it's going to take half a second to retrieve anything out there. So you don't want to put really, really important metadata in there. You don't want to put the text of your HTML in there, because 0.5 seconds is an eternity for a user to wait for your HTML to come back. You should be putting your HTML in memory, the very fastest thing that you can think of. So either put it actually in memory, or put it in a cache that holds it in memory, or put it in Redis, which is pretty like memory. Put absolutely anything that you can reasonably put into memory faster, because getting stuff off of a hard disk or getting stuff off of S3 is exactly as slow as putting your computer in Australia. That's how slow it is. So we are beginning to approach the end. And we're going to start climbing back up the stack, like I said. And the next thing up the stack is testing. Testing was extremely frequently mentioned again as a thing that junior developers arrive on the first day knowing nothing about, because in a bootcamp environment, testing is not really very important. Mostly what you're doing is you're writing prototypes and you're going to throw them away. You're not going to have the kind of long-term problems that testing is designed to solve, so it's fine in a bootcamp situation to write stuff without writing tests. I don't blame you for it. However, as soon as you get into a real working environment, you're going to need to be really, really good at tests, because everything you do is going to hang around forever. And the person who it's going to hurt is you 6 months from now. You're going to write something today, and 6 months from now, someone's going to ask you to make a change to that thing, and you are not going to remember a fucking thing about how that worked, because you were a different person 6 months ago, and your entire personality has changed, and you've moved house, and you've broken up with somebody, and you can't remember anything about that code you wrote. If you wrote good tests, then the tests will tell you everything you need to know. The tests will tell you that everything is working as expected, and if you change something, it will tell you that everything is still working as expected, but you added the feature that you were trying to add. If you don't have tests, then you're just rolling the dice. You're like, well, I think this changed things, but I can't remember how I implemented any of this shit. So it's, 6 to 5, and we have no idea if it's going to work. Tests, like security, are one of those things that take time up front. You're going to have to add time. You can't write your tests all at the end. You have to write your tests as you're doing stuff, and it's going to slow you down. So you have to build it into the time that you're expecting to spend building this web app, because you're going to need the tests later, and it's going to be really painful to slow yourself down on purpose to write these tests when you're trying to ship something by Tuesday. The other thing that tests do is that they make you a lot faster eventually. So I talked about how automating things makes things faster. Testing is one of those places where you really, really want to automate, because testing is a gigantic pain in the ass, right? You have to step through every screen of your buy process to make sure all of the buttons work, and that you can select stuff from the drop-down, and then you can delete things from your shopping cart and all of that stuff. It would take forever to do all of that stuff manually every time you changed any one thing. So just turn it into tests. Have a command called test that you hit and it runs, and everything is green, and you know that you're good to go. Boil down hours of clicking into 15 seconds of running your tests. If you can't figure out how to automate your tests, then the next best thing is to just write down the steps for testing something. Just write manual tests, because again, you're not going to remember 6 months from now what it was that you used to do to make sure that this thing was working. And if you've got manually written down test steps, you can use this amazing thing called interns, where you give the intern the tests to run, and you get them to click through the stupid buy process every time you need to test it. And the most amazing thing about automating by intern is that it magically turns into full automation, because the intern gets bored and figures out how to automate it for you. But any test is better than no test. The other thing about testing is that you should write evil tests. A very common pitfall of junior developers doing testing is that they will test the happy path. They'll say, right, I have a function called add, and I put 2 into it, and I put 2 into it, and the answer was 4. Everything is cool. What if the first number is 2, and the second number is the text of Moby Dick? What happens in that situation? Because somebody misread the instructions on the website, and instead of putting the number 2 into the second box, they accidentally pasted this copy of Moby Dick that they had lying around. Does my web server explode? Does it send an error? Does everything go according to plan? Or does it just print 2? Because 2 plus Moby Dick equals 2 according to JavaScript. Any one of those might be fine. But you need to know which one it is. So you need to write tests that test the evil case. You need to write tests where you're afraid to know what the answer is when the test is run. And the final thing is you should use test data that is constrained and modular. Another common pitfall is to have a thing called a test database where you've just crammed in all of the data you need for all of your tests. And the thing about test databases is they get weird after a while because some of your code was broken and sometimes the data accumulates, and eventually you have tests that only work against the test database or tests that fail against the test database but work in production. And then you're getting into like Wild West territory where you have known failures that are going to be fine in production except they're not, and suddenly stuff is breaking in production even though you thought your tests were fine. It's a nightmare. Have very small chunks of test data that work only with the thing that you're testing. And never have known failures. The only suitable situation for your test suite is to have 100% green all of the time. If you have 99 successes and 1 failure, then you don't know why it's failing. It might be failing because of the reason that you know about, or the intern might have made a change that morning that's making it fail for some different and significantly more dangerous reason, and suddenly everything looks the same as it did before, but instead of accidentally, instead of adding two and two together incorrectly sometimes, it deletes the database every time it runs because the intern is stupid. And that's a problem because you built into your testing suite this expectation that sometimes things look bad. So, closely related to testing is debugging, again, often mentioned by senior developers as a thing that new developers are really bad at. The number one way to be bad at debugging is being superstitious. So, you found a bug, and you're like, well, something's going wrong, so I'm going to change this thing, maybe it's that thing, I'll change that thing too, that looks a little bit wrong, and I'll replace this bit of code with something else. You've made 5 changes all at once, and you run it. You don't know what fixed the problem, and you don't know why it fixed the problem. You just changed a bunch of stuff. So now, either it works, or it doesn't work, but either way you're screwed because you don't know what other stuff you've broken, and you don't know why it was broken in the first place. The way to debug is methodically. Form a theory in your head, what it is that you're getting wrong, and then test that theory by changing one thing. If you change that one thing and it fixes the problem, cool. If you change that one thing and it doesn't, change it back, and then try the next thing. Because if you change one thing after another, you still don't know which of the 3 things you changed was important. If you find code in an application, and this is going to happen to you a lot, in a legacy application that you've come into a company that existed before you did, and you don't know what that code does, immediately delete that code. You're either going to find out that that code wasn't necessary, which is great, you've made your application more efficient, or you're going to find out what it was that that code was doing. Either way, you win. Don't commit code if you don't know what it does. Don't superstitiously copy patterns from other chunks of the code base because it looks like that's important. But do write code that you don't know what it does. Because a lot of the time you're going to be exploring APIs to find out what they do. The documentation will only tell you so much. The way that you really learn how an API works is you start running stuff against that API. A really common and easy way to test something against an API is to write a very short program that uses only that API and it works. It'll take you about 3 minutes to do and it's fine. But again, it's one of those things you're going to be doing constantly. So take your 3 minutes down to 30 seconds by using the REPL. That's the read eval print loop in JavaScript land. That's the console. In the console, you can just paste in a line of code and hit enter and it works. The 3 minutes that you were using to test this app have gone down to 5 or 10 seconds, and suddenly you are a 10x programmer because you're doing less of the stuff that you didn't need to do. Oops, I already did that. So the next level of abstraction up is system architecture. System architecture is ridiculously difficult to boil down into anything that I could describe in a talk. But there's a few things that I've learned that are simple enough to say. The first is that you should always be making the simplest possible thing that you can think of. Firstly, because it's going to be way more complicated than you possibly can imagine. And second, because you have to think about constraints. So imagine you're a startup and you've got seed funding that gives you 6 months of runway, and you're like, cool, we've designed this beautiful application, we've tasked out everything, we've hired enough people, it's going to take us 6 months to build. You've already failed because the thing is going to take 3 times longer than you thought it was going to fail, than you thought it was going to take to build. So you're going to hit the 6-month mark, the application will be barely started, and you'll run out of money. If you've got 6 months to build something, the first thing that you should try to build is something that you think is going to take about a week, because it's going to take about 3 weeks. And at the end of the 3 weeks, you'll have something that you can test. You can ship it to users and they'll go, this is horrible and broken, but it does something slightly useful and I like it. That's where you want to be, right? You need to be shipping stuff as fast as possible because the constraints in your head versus the constraints in the real world are very seldom going to match up. The second thing, and this is closely related, is don't build for scale. It's very tempting when you're thinking about building something for the first time and you're designing something and it's all on paper on the whiteboard to go, okay, so this is going to need to have 100,000 users. So we need to build something that's going to scale to 100,000 users or 1 million users or 10 million users or whatever. And again, you don't know that. You don't know how many users it's going to have, and if you spend 6 months building something complicated enough to be able to withstand 10 million users, again, you're probably going to run out of money, and also that probably won't be the thing that doesn't scale, right? Like, it let you post text and images, and you discovered that you made it possible to post 10,000 pieces of text per second, but only 1 image per second, because you didn't realize that this thing was going to become a fucking meme factory, and everybody would be running images through it all the time. You have no idea what your application is going to really turn into once it hits the user, so don't try to scale it. If you are expecting 10,000 users, start with something that works for 100 users and give it to 100 users and see what happens. And then, if it works and everybody loves it, that's a great problem to have. Hire some more people, throw the first one away and build it again. Intertwined with architecture is the idea of frameworks. People are always arguing about frameworks, especially in the world of JavaScript. The key thing to remember about frameworks is that the advantage of a framework is not a technical advantage, but it's a human one. The granddaddy of frameworks is Ruby on Rails. Ruby on Rails is an excellent framework that runs on an absolute dog of a language. It's a terrible language. I hate it. I can't stand the things that it does. But Ruby on Rails, Ruby on Rails completely changed web development. Before Ruby on Rails existed, the process of hiring a new web developer was a 3-month process. You brought somebody in and you were like, here is where the database queries go, here's how the HTML works, this is the random place that we decided to keep our CSS, except some of it is over here, and also some of that's also a database query. And it would take them 3 months to figure out where everything was, and it took forever. Ruby on Rails changed that time to 1 second. You walked in the door and you're like, is it a Rails app? Cool, I know how to get started. That massively revolutionized how much it cost to build a web app. Because think about like startups, they have like 6 months of runway. You've gone from like the first 3 months getting somebody onboarded to 0 seconds. That startup has twice as much runway. Like a huge explosion of innovation in web application development was the result of Ruby on Rails, so I give it absolute credit for that. But the advantage wasn't technical. The advantage was that a human could walk into your office and get started on the first day. And that's true of all frameworks. Like, the advantage of a framework is that everybody knows the framework is there. So it doesn't matter what framework you use as long as you don't invent your own framework. If you've invented your own framework, you've thrown the advantage of a framework out of the window, because the only thing that that framework gets you is that you don't have to tell other people how it works. If you made your own, then you have to explain to them how it works, and it's a pain in the ass. So pick a framework and go with it. If you want to write stuff in Ruby on Rails, that's cool. I don't have to work on it, but there's lots of others. The only other architectural principle I bothered to include is the principle of modularity. It's kind of obvious because I work at NPM, and NPM is the world's largest store of modules that anyone has ever thought of. So understandably, I kind of think modularity is good, but why do I think modularity is good? And again, it's because it helps humans work. Modularity is a mechanism that allows teams to scale up. If you think about a good complex web application, it's going to have maybe 100,000 lines of code in it, like a really good one that's doing a bunch of useful shit for you. There is no possible way that a single human can hold in their head what 100,000 lines of code do. There is no possible way. Our brains aren't that big. We're monkeys and we're not very good at it. A human can maybe spit 1,000 lines of code into their head at one time, and like have a perfect knowledge of that and be able to change it without needing to think about what's going to break. So if you can break your code into 100,000 lines of code into 1,000 modules, and one human understands each of those modules, then suddenly this impossible task of being able to build a 100,000 line application that still works has become the job of 1,000 people, or sorry, 100 people doing something that is completely approachable. Each of these 100 people can understand one thing. All they need to understand is the contracts between the modules. Instead of me needing to understand what my 1,000 lines of code does and all of the possible other things that it could interact with, all I need to know is that my tests still pass and my contract is still fulfilled so that everybody else can continue to use my module. I can continue to upgrade, I can add new features, I can do a whole bunch of stuff, and I know it's not going to break anybody because I have tests and I have an API service. This is how companies get big. If you aren't splitting your code into modules in some way, then your code is going to hit some kind of scaling barrier beyond which your team is no longer able to change anything without breaking everything. So, climbing back up to the top of the stack, we come to what are called soft skills, which is a completely bullshit term because they are the hardest skills in the industry. They are impossible to master, they take a lifetime to learn, and we undervalue them, and the way that you can tell that we undervalue them is we refer to them as soft skills. We think they're easy, and we should stop doing that. The most important principle of soft skills, in fact, really the only one, is don't be an asshole. Don't belittle people, don't undervalue the non-technical people in your organization. Coders have this idea in their heads that, without the coders, the company doesn't have anything to sell. So the sales department they're our slaves, and, the marketing department doesn't matter. And without the sales department, nobody would buy all of that code you wrote. Without the marketing department, nobody would have heard of you. Without the managers, nobody would know what the fuck is going on most of the time. And without HR, everybody would be sexually harassing each other and doing code in the bathrooms. Everybody is equally important to the edifice not going off the rails, and you can think, and you do not have to think very hard at all to think of a company that violated one of those principles, or multiple of those principles in the case of Uber. Thinking that coding is paramount and that all of the other stuff is just some accidental side effect of how a startup should run is how things go horribly, horribly wrong. And you should also not let the power go to your head. This is a strange time in the world when coders are ridiculously paid. You're going to walk out of here and people are going to offer you $250,000 to $500,000 to do your job, which is an absurd amount of money. And it's very easy when you've suddenly gone from I'm a broke person at a boot camp to I'm earning $250,000 for basically hitting little bits of plastic with my fingers to think I am a better person than I used to be. It's very easy to think that your salary is part of your worth as a human being. And one of the reasons that there are huge social problems in San Francisco is that this city is full of people who think that their very high salaries also make them very good people, and that is not true, and it's something you need to erase from your brain. So be nice and be helpful and be kind. And then maybe when the pitchforks come out, we will not be the first against the wall. The next thing is to value yourself. This is one of those places where your interests and your employer's interests are not going to be aligned, because your employer is going to be interested in you writing as much code as possible, as fast as possible, and if the strain of doing that breaks you a year later and you burn out, you're the one who's burned out, and the employer will just hire somebody else. For your safety, for your career, you need to make sure that everything you do is sustainable. And one of the things that's not sustainable is working more than 40 hours a week. This is not some arbitrary number that we picked out of the air. This is a number that has more than 120 years of research behind it. They first discovered it when mass production was invented, and they were putting cars together for the first time, and they tried to get people to work 70, 80 hours a week putting cars together, and they discovered that they could make almost no cars because everybody was exhausted, so they kept dropping huge chunks of steel on each other and injuring themselves, which stopped production. They discovered that it was unsafe to work people more than about 40 hours a week. Past 40 hours a week, a long stretch of work would completely destroy everyone's productivity and they wouldn't make any cars. this is a graph of how your productivity works. Crunch mode is a thing that can work, and it feels like it works, and you're not wrong that it works, but it only works for a short time, and then you have to pay it back. You are borrowing when you use crunch mode. This is your productivity in the first 4 weeks of crunch mode. You are doing okay. You are doing better than this person who's working 40 hours a week. At the 4-week mark, you are less good than you used to be. And by 8 weeks, you're exactly as good as the person who's been doing 40 hours a week the entire time, except you are now down here, and they are up there. They can continue for the next month and be fine, whereas you are going to spend another month climbing back out of the hole. So 6 weeks in, somebody in permanent crunch mode is significantly worse off. 3 months in. 3 months in, somebody who's trying to do crunch mode all the time is significantly worse off than somebody who just worked 40 hours per week the whole time. And this is something that startups don't understand and refuse to understand and continue to try to pretend isn't true, despite literally 100 years of this research telling them that it's true. And also don't work in crunch mode because it's just awful. It sucks not having weekends, and it sucks not being able to sleep and eat and go to the gym occasionally. Like, it's not worth your health. I just finished telling you that people are going to offer you these absurd sums of money to do the kind of work that you like doing anyway. Why on earth would you work for somebody who makes you have a miserable lifestyle when you could go to any other company and do exactly the same thing, but go home at the end of the day without somebody scowling at you? Why do we as web developers use this enormous economic leverage that we have to be like, give us free snacks and table massages rather than weekends and longer vacations? Like, we could ask for anything. We should ask for a better lifestyle and not just more money. So, now a little bit more career advice. Never work alone. There's 2 ways that I mean this. The first is, as a new developer, again, the money comes into this. As a new developer, you've just started at a new job. They're going to pay you this absurd amount of money, and you're like, shit, I must be really good at this. And you're going to walk in the first day, and there's going to be something you don't know. And because you're like, you spent the entire interview convincing them that you are a super genius, and they've paid you all of this money, you're like, I need to figure this out on my own, otherwise everyone's going to think I'm an imposter. No. If it takes you an hour to figure it out by yourself, and it would have taken 10 minutes for you to lean over to the person next to you and ask them how to do it, then you have cost the company an hour for no reason, right? The whole company is going to go better if after the first 5 minutes of struggling by yourself, you lean over and say, how do you do this again? And they're like, oh, just run the test suite, you're doing that wrong, right? They're going to know, and it's going to be better for you, it's going to be better for them to ask for help occasionally. And the second way that I mean don't work alone is I mean don't be the only tech person at your company. If somebody is like, we've only got a team of 3 developers and 1,000 other people, do not work there. I don't care what it is that they do, because if you work with too few other people, you develop this sort of Galapagos tortoise syndrome where you get weird habits and strange adaptations and funny idioms that only work in the little island that you're on. And if you try to go any other island, you can't eat the berries and you die, right? You become a developer who can only do the kind of development that you already know how to do. Can I save your question to the end? The last bit of career advice is keep learning. Your skills have a shelf life, and it's really short. The stuff that you learn now is going to be obsolete 6 months from now. Not totally obsolete. Some of these skills will last forever. That's the kind of stuff that I've tried to put into this talk. But a lot of your on the ground, this is how this API works, this is how these things fit together, that stuff will have changed beyond recognition 6 months from now. That means that you need to do 2 things. It means you need to be constantly learning the new stuff, and it also means that you should be sharing the stuff you already know as fast as possible, because it only works if you share it as fast as possible. You have to give it to people before it expires. So read articles, preferably not on Hacker News. Go to meetups, go to conferences. If you have a full-time job, you can get them to pay you to go to conferences, and you can get them to pay you to do training, and it's fantastic. And like I said, you should share what you already know. You should share it while it's fresh. You should write, you should blog, and you should talk. And if you can turn the stuff that you know into open source software and throw it over the wall to the world, then you should absolutely do so, because that's a fantastic way to take this bit of knowledge that you have right now and turn it into this self-sustaining beast that runs forever, because new people show up and they modify it to deal with the changing conditions. And this problem that you solved once becomes a problem that solves itself forever. That's the promise of open source. And the other reason that you should do this is because it's just how we do things. The tech industry goes faster and develops faster and has taken over more of the economy of the world than any other industry in the history of anything. And one of the reasons it does that is because deep into the DNA of tech is that we share what we know. When a car manufacturer discovers a new way to build a car, they don't immediately go and do a conference talk about this is a great way to build cars. No, they keep it secret and they patent it and they make it a trade secret, but that's not how we work. The thing that we do is if we discover a really great way of doing something, we immediately tell everybody about it, and everybody goes faster. That is the culture of tech built into the DNA. And that is why I'm here, because I've been in this industry for 22 years, and for the last 22 years, people who have had no vested interest in me doing well sat me down and said, this is how you do this. You should do that, you're doing that wrong, here's a talk, here's an interview, here's a coffee, here's a conference talk, whatever. A bunch of people who got nothing out of it sat me down and told me how to be the person I am today, and the only thing I can do is pay that forward. I can't pay it back. So that's why I'm here. Finally, you have to get a job, which is probably foremost on your minds if you're about to graduate. I have some bad news for you about interviewing, which is that people are really bad at it. It's not going to be you, it's going to be them. They're going to give you stupid interview questions that you nevertheless have to master. Julia wrote a wonderful post about how to get through the modern technical interview and the kinds of things that you're going to need to do. You're going to get these links at the end, so you don't need to write them down. And she's great at it. But what I'd like you to read is also this second one, which is a blog post I wrote about how to give a good interview. Because once you're in the door, you're going to start giving the interviews. And the reason everybody's technical interviews are bad is because everybody interviews the way that they were interviewed. And somebody in like the 60s was really bad at giving interviews, and everybody has been copying it since then. They give interviews where they're like, solve this algorithm on a whiteboard, as if anybody has ever written any code that they actually intended to use on a whiteboard. Why on earth did we decide that was a thing? And do it under time pressure while I'm watching and judging you every time you put a semicolon in the wrong place, right? Like, that's not how coding works. And yet that is how we give interviews. My big tip for interviews is be nervous. It is normal to be nervous, so just own the nervousness. Say that I am nervous. Say, I don't know if you don't know. Don't under any circumstances try to bluff, because the person who has asked you the question knows the answer to the question. That's why they asked you. So if you try to bluff, not only will they know you didn't know the answer to that question, they'll also think that you think they're an idiot, and that they wouldn't notice that you didn't know the answer. So be honest in interviews about what you don't know, and move on to the thing that you do know. Pivot, ask, guess. Just say that you're guessing. Own the nervousness and own the stuff that you don't know. Right at the beginning, I talked about imposter syndrome. One of the problems with imposter syndrome is that the only way to fight it is to get objective opinions about how good you are. And it's very hard to find objective opinions because people are monkeys with all sorts of weird biases about who is good and who is bad at stuff. And one of the ways to fight imposter syndrome is to gang up with people who look like you, or act like you, or are like you in some way. And this is a long list of people of groups like that. I run the one at the top, and the other ones are all run by a bunch of friends of mine. People who are in your crowd will give you more objective opinions than people who are not in your crowd. Another way to fight imposter syndrome, or to fight bias in the tech industry, white guys in the audience. This industry is set up for you. This industry is all about you. This industry loves you and wants you to be successful. You will get jobs that you don't deserve. You will get listened to when you don't deserve to be listened to. And you will get money that you didn't earn. The thing that you have to do is to turn around and put down ladders behind you and make sure that the people who are being ignored are not being ignored. And you have to speak up when other people are being run over. And everybody else, this slide's for you. Here's all of the stuff that I totally skipped, even after 2 hours. There's a long list of stuff that I didn't talk about, and this is it. There's a 2-hour version of this talk that has a little bit more of this stuff in it on YouTube. The web is amazing. After 22 years of working on the web, every time I talk about it to people, I still get filled with excitement about all of the stuff that I can do and all the stuff that it's about to be able to do tomorrow. And I hope that I've communicated to you some of that enthusiasm, and I hope that you enjoy spending the next 22 years exploring it, because I'm done.